A warm welcome to my 24th video of engineering thermodynamics, and thanks for your continuous understanding and cooperation and watching my videos. I am Dr.SUJA. This is for engineering thermodynamics, and this is my sixth video for third unit, that is properties of pure substances and its applications. In the last 5 videos, after we have discussed about the fundamentals and the root and cause of the steam utilization and its applications to various power plants and machineries and devices and industry applications, how we can convert the steam into the good quality, so that more and more work could be extracted from its could be extracted. And now in this video we will continue the PV diagram which we have discussed in the last two videos, the updated version or the improvised views of PVT surface diagram, that is pressure, volume, temperature surface diagram. The importance about this PVT surface diagram is you can see the variations of pressure, volume, temperature in a single coordinate, that is a single diagram or plot, by which you can able to see when and which place the various phases is being occurring, and they are coexisting and they are getting the equilibrium condition. So here you can able to see very clearly, this is the dome which we have drawn, right? PV, can you able to see, students? PV, this we have drawn, no? PV coordinate, this diagram we got, this is constant temperature lines, no? Constant temperature lines, and this is the critical top of the PV diagram is critical point where critical pressure and critical temperature line is here, it is moving, no? And this is the critical pressure. If you straight to this critical point, if you draw and if you meet it, you will get the critical volume, and pressure is in the vertical direction. So this is the pressure, that is temperature line, and corresponding the critical pressure line. So now here another one more thing I told, between these two extremes, or the covering or outer coverage of the vapor dome is nothing but liquid to vapor converting lines. Okay, at critical point there is no need of any heat supply, and this is the triple point. Already I told you, no, 0.01 degree Celsius and about 6.1 kilopascal means you will get this triple point where all the solid, vapor and liquid will be coexisting here. Okay, and all the other terms I hope I would have told about. This what is this envelope consists of, this outer envelope is nothing but consists of all the three coordinates P, V and T. Okay, so that you can see here. And now this is the combination of, again already separately we studied PT and PV diagram. Here it was shown with various important points of critical and triple point. Here the various phases also you can able to see. This is solid to liquid conversion, that is melting process, fusion curve. This is for melting process, fusion curve, converting solid to liquid. Solid to liquid means what, ma? This is ice to water conversion. This is sublimation curve, and sublimation process takes place. That is above this pressure, solid would be converted to vapor. Below this pressure, solid, that is a vapor, would be suddenly converted, that is transferred to ice. Okay, this is the sublimation curve, and this negative slope that was already explained you because of the volume reduction during the fusion process. And this is vaporization curve. The evaporation or vaporization takes place from liquid to vapor or vapor to liquid, that is either vaporization or condensation will takes place. Here you will be getting either melting or freezing will takes place. Here sublimation will takes place. Okay, and in the same manner, here if you see this is PV diagram, which shows about the critical point and the critical temperature, above critical temperature, here below critical temperature. This is the temperature which crosses through the via critical point. And here you are getting that is vapor dome left side. You can able to see solid state. This is that existence of a triple point where all the solid, vapor, liquid coexisting. Here you can see solid, vapor coexistence equilibrium point. Here liquid, vapor. So if you keep here, you can get the all the three phases will coexist with each other, right? And this is also another one more view which shows here you can able to see clearly that constant pressure line which shows the solid liquid state here, liquid vapor, solid liquid here in this region. And after the vapor dome you will get only vapor state, and below the triple point you will get solid vapor region. And left side to this vapor dome you will get the solid, and this is in between region because of the decrease, that is volume decrease due to the during the fusion. Okay, again here some more enrichment diagrams. Already I think I have shown this one, right? I already explained you everything. This is solid, only one solid liquid line due to this peculiar property of the water, and this is solid, and this is vapor phase, this is solid vapor phase, and critical point. So many times I hope that we have done the recalling process, so that my dear students, please keep on preparing this particular fundamental PV diagram and PT and other HS and TS diagram which we are going to study, which will help you throughout this unit. Not only in this unit, in so many thermal application subjects also you will be getting these concepts as basics, and you will be applying these concepts for problem solving. Okay. Now I have given the definition for triple point is a line on the PV diagram where all the three phases, solid, liquid and gas, exist in equilibrium condition. At the pressure below the triple point, the substance cannot exist in the liquid phase. The substance, when heated, transformed from solid to vapor, known as sublimation, and by observing the latent heat of sublimation from the surrounding. Can you able to see? Already I explained you this one. Below this triple point, solid would be converted to vapor, and vapor would be cooled to solid. There could not be able to see the liquid region here. Okay, so by observing or rejecting the latent heat of sublimation, only these two phases only would be present. Okay, the region below the triple point line is therefore called a solid vapor mixture line. Okay, so here are some of the critical pressure and temperature values, that is critical temperature and pressure values for various substance has been given. Okay, and note it down and you can make use of it. Now here let me give an introduction about TS diagram and HS diagram, and we will meet you in the next video. I will explain you in detail. As how I told, PV diagram and PVPT, PVT diagrams are deliberately expressing the each and every nook and corner of the steam properties with the very tiny amount of intervals, so that we could be able to draw in PV or PT coordinate, since we have assumed that all the conditions which were received achieved by that particular process are in thermodynamic equilibrium, like that. Not only PV, PT and PVT diagrams are sufficient enough to explore in detail. Further, TS diagram and HS diagram. S means entropy. In the 2 units we would have studied about what is entropy and its importance. So entropy is the property that shows the degradation of energy, that is how much effectively the heat transfer has arrested from the system to surrounding or surrounding to system, how much effectively the heat transfer processes have taken place, was told by this is the signpost of measuring the quality of the experiments. So S is a very important measurement that shows how much the system properties and the devices and their parts are whether they are affected or not because of the high temperature and high pressure supplied to them, how much degradation of energy and the effect on the equipment, the parts of the equipment, and how much the quality of the final outcome, everything can be found out by this property S. And that entropy S is has been plotted with along with temperature and as well as enthalpy, and from the next video onwards we will study in detail about how to draw TS diagram and HS diagram. And another one more important thing is TS, wherever you have to calculate the heat transferred during that particular process, it is very much easy for you to have the TS diagram, because if you know, if you can draw the TS diagram within a fraction, you can able to find out the heat transferred. And the importance of, as far as HS diagram is concerned, it is not only having H and S in its coordinate, but also all the properties are existing in a single chart, which is called Mollier chart. Only drawing the steps to get these diagrams should be learned, and once if you explore the processes or steps to be taken to find out these properties, then it would be very easy for you not only to know only that particular properties H, S, T, apart from which pressure, volume, quality of the steam, and all other properties can be was included in a single chart, which is called Mollier chart. Okay, so let me meet you in the next video with the procedures for drawing TS diagram and HS diagram. Meet you soon, my dear students. I am signing off. Thanks for patient listening, and always your understanding and knowledge enrichment will be supported by my video. Believing this, signing off, Dr. Suja.